Welcome back to our trigonometry series. Today we are up to section 1.2 where we will be looking at angles in the coordinate plane. Last time we looked at the unit circle. This is a circle on the xy plane that has a radius of 1 and is centered at the origin, or where x and y are both 0. We also discussed that in trigonometry we use theta to represent angles as a variable. Here we can see that theta is equal to 45 degrees. Let's start off with an empty xy plane and draw a ray on the x-axis. Next, we'll rotate up and draw a second ray. And here we have an angle. An angle is defined as a union of two rays with a common endpoint, known as the vertex. In trigonometry, an angle is formed by rotating a ray about its vertex from one position, called the initial side, to another, called the terminal side. So here we can see on the bottom, along the x-axis, is the initial side, and we rotate it up to the terminal side. When the vertex of an angle is the origin of the coordinate plane, as shown here, and its initial side coincides with the x-axis, as shown here, the angle is said to be in standard position. This is what we'll be using the vast majority of the time during trigonometry. If the angle is formed by a counterclockwise rotation, its measure is positive. If an angle is formed by a clockwise rotation, its measure is negative. So here we can see we've rotated counterclockwise, so we have a positive rotation. Typically, angles are measured in degrees. One full rotation is 360 degrees, and typically we use this round circle bubble to denote degrees as a unit. This is an example of rotating 180 degrees counterclockwise, or a positive direction. We would end up in the same place if we rotated a negative 180 degrees, or a clockwise direction. Turns out, angle rotation is not limited to 360 degrees. If you look at this drawing, we've rotated positively, or counterclockwise, all the way around and ended up at this angle. Between the initial and terminal sides, we are at 60 degrees. So what is the total rotation? Well, we went around once, so that's 360 degrees. We then rotated an additional 60 degrees. So the total rotation, or theta, is 420 degrees. So on the xy plane, 60 degrees and 400 degrees are coterminal. They end up at the same place in the xy plane. Let's jump over to the whiteboard and do some examples. So I'm going to start by drawing a small xy plane up here, like this. And here's our x, and here's our y. And what we want to draw is a 1/4 rotation clockwise. Remember, clockwise would be a negative rotation. And we're going to have our standard form. So we have our initial side along the x-axis. So if our initial side is along the x-axis, we'll make it a little thicker here, and we go 1/4 of the way around, clockwise, because it's negative, would be to here. So theta would be between our two thick lines. So theta would equal a negative 90 degrees because we went clockwise. I'll do another example right down here. Drawing our xy plane. Let's do 1/2 of a rotation, but this time we'll go counterclockwise. So we're going to go this way around the axes here. But since it's counterclockwise, it's a positive measurement. So we're going to start from our initial side, our normal along the x-axis here, and rotate halfway around the circle, like this, to here. And this is like the example we saw in the slides. This would be a positive 180 degrees. You don't need to put the positive, but we're showing for example's sake, because it's a counterclockwise, this is a positive measurement. Next, I'm going to draw a slightly larger one here for our example. Oop, getting a little sloppy with my arrows here. Again, we like to mark our axes, x and y. And we're going to start with a measurement. Let's say, we'll put it down here. Theta equals 40 degrees. So using our standard form, we've got our initial side, and 40 degrees is about here. I'm just kind of eyeballing it like that. So here is our 40 degrees. Now what I want to do is we'll call this theta 1. I'm going to put theta 2, that's almost a theta, theta 3. And I want one of these to be a positive rotation, and one of these to be a negative rotation that are coterminal with the original theta, theta 1, which is here, theta 1. So a positive would be this way. But we want to end up at the same place. We want to be coterminal. So we end up at the same place, coterminal. We end up in the same place. So if we start here in our standard spot and we want to rotate, we're going to have to go around past the 40, all the way around, and then end up at the 40 again. So in this case, we did 360. We went around the circle once, and then we added 40 to get back to this angle here to be coterminal. So this one is 400 degrees. For this last example, we want to be a negative rotation. So we have to start at our same spot, but go the other way. And we'll be on the inside this time. So if we go this way, we're going negative, because we're going clockwise. We end up here. Now we didn't have to go all the way around. We didn't make it 360. But in this case, we only made it 320. So in this case, it's 320 degrees, because it was the 360 minus the 40. We didn't have to go all the way around. We stopped before we got back to where we started. There's a 40-degree gap between where we were and a full circle. Full circle minus the 40 gives us 320 degrees. That's very poorly written. That's it for today. It's a pretty short section, but we'll see you next time.